presentation will focus upon cross-curricular issues within science and maths. The main points addressed within this presentation will be pros and cons of cross-curricular approaches to maths and science, the relationship between the two subjects, and the use of ICT in children's learning. The issue around the importance of integrating the subjects maths and science has been debated for many years. Research going back to the 1800s shows that cross-curricular debates have been an ongoing discussion leading up to the present day. Frickholm and Glassam believe that if the two subjects are not taught connectively, then the concept can be lost and that students will not be able to solve real-life problems. The main themes that have been displayed from the debates have been over the benefits of child-centred and progressive teaching as opposed to the traditional way of teaching. The Forster Act 1870 stated that all districts needed to ensure that sufficient public school provisions were put in place. This year has been described as the year when the government began to take the education system seriously. However, this was only the beginning and would grow and develop over the next 2 decades before the process was complete. The outcomes of this Act with regards to the curriculum are that it was very restricted and was almost entirely based on the 3 R's, reading, writing and arithmetic. The main objectives of this Act were for obedience and conformity. Blythe 1965 argued that the education system at this point was limited and inferior, therefore requiring much improvement. In 1967 came about the Plowden Report. Plowden believed that at the heart of education lies the child, and not the child as a collective, but the child as an individual. One of the main tasks stated in the report is that primary schools need to build upon their intrinsic interest of learning and lead them to learn by themselves. A statement made by Plowden that is very influential is that teachers should not assume that only what is measurable is valuable. Rose Review carefully looked at and reviewed schools and found that the effective schools were those where a curriculum was planned that provided children with specialist subject teaching and cross-curricular teaching. These findings were to be put forward to improve a new curriculum. The 2014 National Curriculum has now incorporated more on cross-curricular learning and with regards to maths and science states that teachers should use every relevant subject to develop pupils' mathematical fluency, and this is a precondition of success across the curriculum. Today, ICT is playing a much more prominent part in schools, both for children and for teachers. I believe that it is important for schools to integrate ICT within all subjects due to this very reason, although it is important to remember that it only should be used if it can have a positive impact on children's learning. Hativa and Cohen's research showed evidence of the impact of ICT on practicing skills using programs that focus on learning, such as learning about negative numbers in mathematics and on early reading, as demonstrated in research by Medusa et al. I believe that children need to have all the tools available to them that will assist them in learning and understanding the importance of reading and writing, and ensuring that they can do these skills to the best of their ability. ICT can play a huge part in developing this skill, as researched by Goldberg, Russell and Cook, who stated that students who use computers when learning to write are not only more engaged and motivated in their writing, but also produce work at a greater length and quality. Using ICT can help children understand the importance of being able to present data and information in various formats. This is also the case for teachers. The use of ICT can enable teachers to use a variety of different methods and disciplines to display information to children, which can help with engagement. The use of ICT is sometimes restricted to spreadsheet data, however it can also be beneficial in literacy. The use of ICT is also an important part of the cross-curricular debate, as using it can show children the strong relationships between maths and science more clearly. Teachers play a big part in helping ICT and technology to be brought into the classroom. It is something that will take time, and I believe all teachers should be made aware of the wide range of benefits ICT can bring. Teachers need to ensure that their use of computers within the classroom is effective, and I agree with the comments of Sandhorst that it will take time and commitment for ICT to be used to its full potential within the classroom. Although I believe that ICT is a necessity, it is also incredibly important to remember that technology is always changing, and if it is to be adopted into the classroom more prominently, it is important that the classroom moves along at the same speed as the technology. With any changes that are made within the education system, it is incredibly important to consider the implications on assessment. Assessment, I believe, may be one of the challenges for teachers who are developing a cross-curricular approach. Ofsted and Kerry state that well-planned cross-curricular work can have a positive impact on achievements, which is evidenced through tests and exams. However, studies by Venville et al. And Rennie et al. State that the difficulty of assessing children's learning when using a cross-curricular approach is that traditional forms of assessment are limited because they tend to focus on assessing subject-specific knowledge and concepts and do not take account of how children apply subject-specific knowledge. It is important to understand that this should not be an excuse for not assessing children's learning. It is just an obstacle that needs to be dealt with and adapted to fit with cross-curricular teaching. For teachers is already classed as a stressful part of the job. I believe that with the subjects such as maths and science, because there is a strong link between the two subjects and some lessons planned for maths are already interlinked with science and vice versa, for this reason, I do not think the planning of cross-curricular between the two subjects would cause any particular problems. Like all aspects of change, it is just something that needs to be put into practice. However, this may not be the case for all subjects, as some other subjects do not have such a strong connection as maths and science, and therefore may pose problems when it comes down to planning. One of the concerns is that by teaching cross-curricular, some subjects may lose their identity as the focus of the planning will have shifted. Curricular teaching has been said to have similarities to the constructivist theory. Constructivism is a theory of learning whereby the focus is on what might be going on inside the mind of the learner. The arguments that support the constructivist approach are based on an understanding of child development. This theory is also supported by the Plowden report, which states that children's learning does not fit into neat subject categories. It is this that is linked in with the cross-curricular approach. Similar to the constructivist theory, they both would involve subjects not being taught as separate entities, but taught as interlinking subjects. Like most approaches, there are both pros and cons to teaching maths and science cross-curricular. I agree with the views of Ofsted that children should be taught to be able to apply the knowledge they get from one subject to another. Knowledge learnt in maths is transferable to science and vice versa. Another benefit of teaching maths as a connected subject is it can help children who are not so passionate about one of the subjects but like the other understand how they are not that different, allowing the children to engage in both of the subjects and possibly even excel in both of the subjects. I believe that having an understanding of the connection and how we can use these skills throughout our lives and not just at school needs to be instilled from a young age and maintained throughout the school process. Carr makes the statement that children learning facts about different subjects is not enough. They need to understand the connections between different subjects and use understanding of their own experiences to fully engage with and understand a topic. When the topics taught are stripped down, it is clearer to see how maths and science are related. Sometimes we may be doing one of the subjects and not even realise that we are using skills that we have learned from the other. For example, when creating spreadsheets of scientific data, we are also using the skills and knowledge that we have learned from maths to create formulas that make creating that spreadsheet easier. The main disadvantages that I can see to maths and science being taught cross-curricular is the fact that both maths and science are difficult subjects to grasp the concept of, and if not planned right, the maths could get lost in the science and the science could get lost in the maths. I think it is important to ensure that a basic knowledge of maths and science individually needs to be ensured before the two are looked at connectively. If this is ensured, then I don't believe a problem is created. However, if this is not followed, I believe it could be non-beneficial to children's experiences of the two subjects. In conclusion, taking into account the brief history of the cross-curriculum approach discussed throughout the presentation, I believe it would be beneficial to both children's education and teachers for maths and science to be taught cross-curricular. There are studies and research that support the theory that cross-curricular would be a beneficial approach to adopt in schools for various reasons. I feel that for it to be successful, it needs to be developed before it is implemented in schools, and teachers need to have the correct help and resources given to them to be able to use the cross-curricular approach effectively. With regards to maths and science, I believe the transition could be quite smooth due to the very strong link between the two subjects. This, however, may not be the case for all subjects as discussed previously. Feasey says that at the heart of science is maths. I believe this to be the case in many aspects and think that the connection between maths and science needs to be more widely recognised and used in schools. Furthermore, I believe that a good understanding of maths can be incredibly beneficial to children later in life, as it is a subject that we'll use throughout our lifetimes. Research has stated that maths is essential to everyday life, critical to science and provides a foundation for understanding the world. Taking this into account, Teaching maths cross-curricular with other subjects, with the main focus being on science, can only be beneficial. However, it is essential that if a cross-curricular approach to maths and science is adopted, it needs to be handled correctly. Teachers need to ensure that they have a clear subject knowledge on maths and science, and they themselves understand the ways the two subjects can be linked, thus giving teachers the opportunity to teach to the best of their ability and allowing children to use their understanding of the separate subjects and fuse that knowledge together to find connections and links. A cross-curricular approach allows children to further their thinking, which is something as teachers put a lot of focus on. For example, questioning children, allowing them to broaden their own thinking without giving them the answer. Using this approach, in my opinion, will only enhance this and get children thinking about how everything can be interlinked and could understand and appreciate the deep relationship between the subjects maths and science.